What challenges do you face during the migration process of a monolithic application into microservices? This is a question that many developers grapple with. One of the primary hurdles is the transition of domain model semantics from the monolithic system to the newly migrated microservices. This is where the anti-corruption layer, ACL pattern, comes into play. It acts as a mediator, translating the model of the upstream bounded context, or the monolith, into a model that suits the downstream bounded context, or the microservice. This ensures seamless communication between the two systems. The anti-corruption layer pattern is particularly beneficial when the downstream bounded context contains a core subdomain, or when the upstream model is an unmodifiable legacy system. In essence, the anti-corruption layer pattern is a vital tool for successful migration, acting as an interpreter between old and new systems. Opening. Why would you need the anti-corruption layer pattern during migration? Well, picture this. You're in the process of migrating a monolithic application into microservices. During this transition, the semantics of the domain model in your newly migrated service might undergo changes. Now here's the challenge. The features within the monolith that need to call these microservices should be able to do so without any changes to the calling services. That's where our hero, the anti-corruption layer, ACL pattern, steps in. The ACL pattern is like a skilled translator, proficient in both the old and new languages of your system. It acts as an adapter or a facade layer, interpreting and translating the calls from the monolith into the newer semantics of the microservices. This allows the monolith to communicate with the microservices seamlessly, as if they speak the same language. Think of the ACL pattern as a diplomatic mediator, ensuring a smooth conversation between two parties speaking different languages. It becomes the bridge between the past and the future, between the monolith and the microservices. But it's not just about translation. The ACL pattern also plays a crucial role in reducing disruption and risks related to transformation. By acting as this mediating layer, it shields the callers from changes, redirecting their calls transparently to the target system. In essence, it ensures that the migration process doesn't affect the operational continuity of the monolith. So in the grand scheme of things, the ACL pattern is like a lifeline during the migration process. It enables the monolith and the microservices to interact without a hitch, ensuring that the semantics of the domain model in the microservices don't become a stumbling block in the communication process. Closing. The ACL pattern ensures seamless interaction between the old monolith and the newly migrated services. It's a key player in making sure your migration process is as smooth as possible, enabling a harmonious coexistence and interaction between the old and the new. When should you consider using the anti-corruption layer pattern? This is what we'll be exploring in this section. The anti-corruption layer, or ACL, has a wide range of applications. It's particularly useful when your existing monolithic application needs to communicate with a function that's migrated into a microservice. Suppose the domain model and semantics of the newly migrated service differ from the original feature. The ACL pattern could be your best bet. It acts as an adapter, facilitating communication between the old and new systems without requiring any changes to the calling services. But the application of this pattern isn't limited to just that. It also comes in handy when two systems with different semantics need to exchange data. In scenarios where modifying one system to be compatible with the other is impractical or impossible, the ACL pattern serves as a mediator, ensuring smooth data exchange. Moreover, if you're looking for a quick and simplified approach to adapt one system to another, the ACL pattern can be a great choice. It minimizes the impact on the systems and reduces the risk of disruption. This pattern can be particularly useful if your application is communicating with an external system. By acting as a translator between the two systems, the ACL pattern can help ensure seamless integration. In essence, the anti-corruption layer pattern is a versatile tool that can be applied in a variety of scenarios. Whether it's bridging the gap between different domain models and semantics, facilitating quick adaptation of systems, or ensuring smooth interaction with external systems, the ACL pattern can be your go-to solution. It's important to remember that every pattern has its place, and the ACL is no exception. It's not a one-size-fits-all solution, but in the right context, it can make a significant difference in how systems interact and function. So, the next time you find yourself in a situation where systems need to interact but have different semantics, or if you need a quick way to adapt one system to another, consider the anti-corruption layer pattern. It might just be the solution you need. The ACL pattern is a versatile tool for smooth integration in a variety of scenarios. What are some potential issues and considerations with the anti-corruption layer pattern? Let's delve into this. One of the primary challenges with the anti-corruption layer, or ACL pattern, is team dependencies. When different services in your system are owned by different teams, the new domain model semantics in the migrated services can lead to changes in the calling systems. However, teams might not always be able to make these changes in a coordinated way due to other priorities. The ACL acts as a buffer, decoupling calls and translating calls to match the semantics of the new services, thus avoiding the need for callers to make changes in the current system. Another significant concern is the operational overhead. Implementing the ACL pattern requires additional effort to operate and maintain. This effort includes integrating the ACL with monitoring and alerting tools, managing the release process, and navigating the complexities of continuous integration and continuous delivery, or CI/CD processes. Next, we need to consider the risk of a single point of failure. If the ACL fails, it can make the target service unreachable, causing application issues. To mitigate this issue, it's crucial to build in retry capabilities and circuit breakers. Setting up appropriate alerts and logging will also improve the mean time to resolution, or MTTR. Technical debt is another vital aspect to consider. As part of your migration or modernization strategy, you need to determine whether the ACL will be a transient or interim solution, or a long-term solution. If it's an interim solution, it's important to record the ACL as a technical debt and plan to decommission it after all dependent callers have been migrated. Finally, let's touch on latency. The additional layer introduced by the ACL can potentially increase latency due to the conversion of requests from one interface to another. This is particularly important for applications that are sensitive to response time. Therefore, it's recommended to define and test performance tolerance in these applications before you implement the ACL pattern. In summary, while the ACL pattern plays a crucial role in making the migration to microservices smoother, it's not without its challenges. You need to be aware of the potential issues such as team dependencies, operational overhead, the risk of a single point of failure, and technical debt. Also, considerations like additional latency and the need for performance tolerance testing should be taken into account. While the ACL pattern can bring numerous benefits, it's essential to consider these potential issues and make informed decisions. What have we learned about the anti-corruption layer pattern? So, the anti-corruption layer, or ACL, is a design pattern that serves as a mediator, translating domain model semantics between different systems. Essentially, it's an adapter that converts the model of an upstream bounded context, typically a monolith, into a model fitting for a downstream bounded context, often a microservice. This way, the communication contract established by the upstream team is consumed effectively. The motivation behind the ACL pattern is to facilitate a smooth migration process. When a monolithic application is broken down into microservices, the domain model semantics of the new services may change. The ACL pattern allows the monolith to call these microservices transparently, acting as a facade layer that translates these calls into the new semantics. This reduces transformation risks and business disruption, ensuring that the system remains reliable and robust. The ACL pattern is particularly applicable when your existing monolithic application needs to communicate with a function that has been migrated to a microservice, and the domain model and semantics of the new service differ from the original feature. It's also a practical solution when two systems with different semantics need to exchange data, but it's not feasible to modify one system to be compatible with the other. However, there are considerations to keep in mind. The ACL pattern can introduce an operational overhead, and potentially become a single point of failure if not managed properly. It requires integration with monitoring, alerting tools, release processes, and CI/CD processes. If the ACL fails, it can render the target service unreachable, leading to application issues. Therefore, building in retry capabilities and circuit breakers, as well as setting up proper alerts and logging, is crucial. Lastly, consider whether the ACL is a transient solution or a long-term one. If it's an interim solution, it should be recorded as a technical debt to be decommissioned once all dependent callers have been migrated. The anti-corruption layer pattern is a powerful tool in the migration process, providing a bridge between Monolith and microservices while addressing potential challenges.